welcome onto the show. Would you like to introduce yourself? Tell us a little bit about what you do for Glue.
Awesome. Thanks, Jordan. Thanks, Jillian. My name is Kinshuk Pahare. I'm a principal product manager on AWS Glue. And primarily, I focus on the things that happen underneath all the UI that Tome was just sharing. So I'm a platform PM, and my team is responsible for all the features that we ship, specifically around Spark engine, Ray engine, and Python engines, plus all the security stuff.
Yeah, I know today's going to be about Glue for Ray, but I think before we get into it, we should go over what exactly Ray is.
Yeah. So let's maybe I'll actually even go, what problems are we trying to solve, right? So what
There we go.
customers are using Glue? Customers are using Glue for data integration. And as Tome was describing, raw data is everywhere. But to make use of that data, which is maybe sitting in a SaaS cloud or in some database, or maybe these are CSV log files which some application generated and they were all in some S3 bucket. Now, as a data user, whether this is business intelligence, AI, ML, you want to make sure that all that raw data can find its way into a data lake or data warehouse so that further downstream applications, like QuickSight or Athena, or your AI ML applications, they can use it in the much more efficient manner possible. So the process of converting this raw data, running it through series of transforms, doing data quality checks, dropping some unnecessary columns, removing some bad records, that entire process is data integration. And that's exactly what Glue does. So Glue is that service which is responsible for data integration. Now, as part of that service and as part of that process, there is obviously the authoring tool, which Shomi was describing, right? So you can author these jobs on Visual Tool, you can write code, you can use Notebook, you can run it through SQL. And to process the data, you need engines. Now, the data processing engines, Spark is one of the most popular data processing engine. Glue service was one of the first service, which actually started with the Spark service, and it was a serverless service. So our goal was to make it easier. We will take care of all the Spark complexity. We will take care of all the, setting up the cluster. You just focus on data integration. Now, with that, we started, that's the genesis of Glue. Recently, what we started hearing from our customers is that, hey, Python is very powerful. We love your Python single shell engine, and it just does an amazing thing. My 11-year-old son is also learning Python. So Python is everywhere.
Wow.
And when you try to process data with Python, that's where distribution comes, or distributing Python becomes a challenge.
Yeah. So we've got a comment which was asking, what about streaming data? So is that the type of data that you could potentially use for data integration?
Absolutely. So the streaming data is also supported with Glue today. You can actually use our existing engines, the Spark engine, which is capable of processing streaming data. And interestingly, I think another question we usually get, right, is that it's the type of the data and then what kind of data they are sending. So data sources and what kind of data. And Glue has built-in connectors. You can build your own connectors and you can ingest different type of data. So
very cool.
Awesome. Yeah, I like that history lesson. So we're now
so now we are in Python. So now Python is a single node engine. Now, the beautiful part of Python is that you do not have to get into the complexity of memory management. And to achieve that, Python has a global interpreter log. So that's the only technical phrase I'm going to use today. And the global interpreter log, while make it easier to actually do memory management, it also makes it difficult to distribute Python across different nodes. And the problem, if you cannot distribute Python across multiple nodes, right? It's just the function of data that you can process. So imagine if you want to process 100 gig of data and you have only 16 gig of memory in your machine, in a single machine. So what you need to do is you need to either have 6 or 7 machines processing data in parallel, and then you need to figure out, how do you want to give them work? Or you wait and process data in chunks. So, maybe 12 gig, 12 gig, 12 gig, 12 gig, right? Depending on how much memory is available to you for processing data. Now, as we started evaluating, and like hundreds of thousands of customers are using this today with Glue, and the feedback we were hearing is, hey, we need an ability for you to sort of give us a distributed version of Python so that we can actually process this hundreds of gigs of data that is sitting in our S3 buckets, raw data, and we want to process that using Python because we love Python. That was the genesis when we actually started looking into, Ray.io, which is a new, computing framework. It was developed originally in Rise Lab Berkeley, and it's an open source framework.
That's where I went to school.
Whoa.
So, which allows us to basically say, you know what? Hey, I love Python. I can distribute Python. But then how do I make it easier for developers and for data integration, users, so that they don't have to worry about, maintaining clusters, running it through, multiple complexities around infrastructure. They just focus on writing the code, and then we take care of rest.
Yeah, super cool. Oh, one thing I wanted to call out is that there is a survey. I'm going to pop it up. So we actually look at these survey results. So please fill out the survey. And the first 50 respondents receive $10 in AWS credits. So
yeah. We want to hear from you. Make the show better.
Of course, right? Yeah,
So,
Jordan, was there something you were gonna say?
Oh no, I was just gonna say that this is very cool.
Yeah.
So
yeah, go ahead.
We do have a demo now. Of course, it's not a cool demo as Tomei. So let's see if I can top him. So this is the screen that I think Tomei was also sharing. So we have the visual ETL, but for this demo, I'm going to focus on the notebook experience. And as you can see here, I have a demo notebook, which I've set it up. What it is doing is it's actually starting the notebook. Now, interestingly, when the notebook is up and running, it's not leading, or it's not going to, your billing doesn't start just yet. So the notebook is going to start. I can write my code in peace. We are not, there is no extra charge for this thing. And this is very important because developing a job could take, a few hours, half a day, maybe a day. And this notebook, you can actually keep editing code, writing code, and we are not starting your billing. I want to actually quickly show you what is available here. So on the help magic, I can just type a help magic, and I can set my profile. I can set the region where I want to run it. And as a developer, this is very handy, right? So now I don't have to actually go and muck up some configuration. It's right there in the notebook. I can just apply these magics, notebook magics, to just set up my my configuration. There was an earlier question. So these are the different type of jobs that are supported. So streaming, Ray. Today we are going to talk about Ray, and obviously there's a Spark job as well. And then configuration, right? So you can set up your IAM role depending on the permission, depending on the data that you want to access. One of the interesting things with Glue is that Glue takes care of some of your, data access problems as well. For example, it integrates with your, KMS, so where you can store username and passwords for all your data stores, so that you don't have to hard code username and passwords in your script, which is just a terribly bad idea. A lot of customers actually develop your, additional modules. So if you want to install some of the data science or some of the work that you have done locally and you want to install it as part of your job, you can install it here. And I think last but not least, my favorite magic is the idle timeout. This is one of the most demanding magic. The key use case, and it's actually very, very real. When you're processing job, and if you're processing, hundreds of gigs of data, sometimes those jobs can take, minutes. If you're processing, terabytes of data, that can take hours. And hey, I just want to execute or kick off this job, and I didn't want to grab a cup of coffee. But I don't want to be in a situation where I am paying for compute when my job has finished. So idle timeout is basically, you can set this up as 5 minutes or 10 minutes, and I'm going to show you how to set it up. And after 10 minutes of calculation and computation, we will take care of, shutting down your compute, and your billing will stop at that time.
Kinshuk, there's a question in the chat, and I want to bring it up. So does Glue for Ray help in this scenario where this customer is saying, hey, what do you do when their data, the schema of your data is continuously changing?
Yeah, so Ray.io actually offers built-in libraries to ensure that the schema, the changes of the schemas are accounted for. And this is, again, it's a fast evolving framework. So, reading a schema, you can actually read it from dataset and just generate the schema and add it to your job accordingly. We will send you the blog post and some of the interesting links. I think Henry is probably answering questions, and we can respond there.
Yeah, Henry's been in the chat. And so there's this link here that Henry dropped where you can go and check out more about the launch announcement. Thanks for dropping that, Henry.
Awesome. So now I have a starting code. And interestingly, what I'm doing is I'm actually setting up auto-scaling. Now, auto-scaling is an interesting feature. Auto-scaling, what it does, it allows you to only right size your cluster to a point where you only pay for the compute that you are actually using. Because what happens, right, is that suppose you have 100 node cluster. About 70 of the workers are done processing the data. They are just sitting idle. Maybe 30 are not done. What we will do is when I set this flag, we will actually identify those 70 workers which are not doing anything. They are done processing the data, and we will shut those down. And what happens? Your billing and your metering for those clusters stops. So this is a really, really cool feature, which enables you to reduce the cost of your data processing. Okay, so now I am going to hit this code block. And what I'm doing is I'm actually saying I just need 10 workers. Idle timeout is 5 minutes. And let's just import some libraries. And I just want to see, how long it took for me to get the session started. So now it's waiting for the session, and session established. And let's see if it's going to print the statement. Okay, so it took 1.4 seconds to get a 10-node Ray cluster in the background.
Wow.
Yeah.
Now, the beauty of this is that if I had set this as 50 or 100, it would have taken similar amount of time. So what we have done to serve this client, what we have done is we have actually invested in a new infrastructure, which gives you this instant on analytics application. So now my billing has started. As I executed this cell, my billing has started. And what is happening in the background is that as a developer, I have not configured any compute instances. I have absolutely no idea how it is happening in the background. I'm just focused on writing code. And when I'm finished developing, I can actually say stop session, right, again, on the notebook itself. And after this, my billing and my metering has stopped. So now the key advantage here is that as a developer, it's amazing, or it's very easy, right? for me to just write the code, set up the infrastructure, get the results back in seconds, instead of having to wait for 10, 15 minutes for compute instances to get started, and then it becomes very, very slow, and it just very frustrating. The fact that I can do this very quickly means that I can actually enable it and disable it and then turn it on again and turn it off again. What happens is that if you have this access and it is fast, it encourages you to use a stop session very frequently. If I have to wait 10 minutes or 15 minutes to get started, guess what? I'm likely to keep that cluster up and running for a longer time, which will increase my cost.
Yeah, I feel like this is where serverless just shines so bright. When you are processing, crazy amounts of data, you would typically have had to, provision all of these compute resources, separately and wait for them to spin up, or maybe even have on-prem, where you're trying to figure out, okay, how can we scale as our data is scaling? Maybe it's streaming data, maybe it's inconsistent. I feel like the fact that this is so fast and it's so responsive to when you're actually trying to do these tasks is a really fantastic customer experience. And I feel like sometimes when I see demos like this, I'm like, oh yeah, it's done, it's over. Like that's almost like, oh, it's so easy. But I know, because I'm on a product team, how much work goes in on the back end to make this super simple 1 second experience of provisioning all of these really complex resources. So hats off to the product team, I guess.
Yeah.
And Jordan, you actually brought up a very good point. So this is an interesting point of on-prem, right? Now, developers, every developer has their favorite development environment, right? What I'm showing right here is a Glue Studio development environment, but the question sometimes comes is hey, I like my Visual Studio Code, or I like my PyCharm, or I like my Jupyter Notebook, which I run on my laptop. So this is an example. This notebook is running locally, and it has the same interface. So all you need to do is install the Glue kernel and do the same type of configuration. It's identical. And here, you can obviously use Visual Studio Code. You can use PyCharm. You can install, a local Jupyter notebook, and you get the same experience. The infrastructure, or I would say the Ray cluster that gets set up in the backend is, again, it's going to be instant on. It's going to be the similar experience.
Really cool. Kinshuk, I have a question, because we've got people of all different experience levels with data engineering, and we just learned about Glue data quality. So how does what we just learned here about with Ray for Glue fit into the whole picture with Glue data quality about the data engineering workflow?
Yeah, so the way we actually, customers are using Ray, and we actually launched the preview at reInvent time, is that there are developers within customers, some developers like Spark, others like SQL, others like Python, and depending on your preference, you actually pick the infrastructure or the computing environment. So Ray is, used by developers and customers who actually are interested in, using Python for data processing need. And they're processing, hundreds and hundreds of gigs of data using Ray.io.
Super cool.
Yeah, it really is.
Well, awesome. Thanks so much. Let's see. Do we have any last questions from the chat about any of the Glue?
I'll show up again. Henry called out the you can learn more here. go.aws/45WLO lowercase x uppercase p. So check that out to really learn more.
Mm-hmm. Yep. Thanks so much, Kinshuk. That was great.
Awesome. Thank you very much.
Perfect. Thanks so much.